depending on your field or discipline, hierarchical, agglomerative clustering and k-means clustering may be the more commonly used clustering methods. And for hierarchical agglomerative clustering, it begins by assigning each observation into a separate cluster. Initially, each of these observations are a separate cluster by itself. And after that, it assesses the distance between that observations to the other observations. And observations with the smallest distance between them are combined into a new cluster. And after that, it's going to reassess the distance of that observation to all the other observations, and then is going to identify observations with the smallest distance between them, and these observations are going to be merged into a new cluster, and then it's going to repeat this step again, examining the distances and then forming new clusters. So these steps will go on and on and on until this is something we see. Eventually, we are going to get one big cluster of all observations, and these may not be what we want given the purpose of our analysis or our research question. The distances among observations are examined and they are being formed into clusters, and then we reassess the distance and then we form new clusters. Eventually we get a big cluster. This may not be what we want. So because of that, we use this criterion to determine the optimal number of clusters. And sometimes it's always good to use more than one criterion when we want to decide on the number of clusters. So if 2 out of the 3 criterion give us the same or a somewhat similar results, then we can be more certain about the optimal number of clusters. So as you can see from here, the hierarchical agglomerative clustering is a bottom-up approach. Initially, all these cases or observations are a cluster by itself. In this case, the observations are the different states in the US. And then, after the distance are being examined, among these observations, they are being formed into clusters initially. 4 or 5 of these states form a small cluster. 4 of these states form another cluster. 2 of these states, or 3 of these states, Connecticut, DC, and Nebraska, form a small cluster. And 4 of these states form another small cluster. 3 of these states form a small cluster. 2 of these states, Kentucky and Minnesota, forms a small cluster, and so on and so forth. And the distances among these observations are reassessed and they are combined in another round to form a bigger cluster. And the distances among the bigger clusters are examined, and then they are formed into new bigger clusters. It goes on and on and on, and eventually we get one big cluster. So this is a graphical depiction of the hierarchical agglomerative clustering. And in this case, we try to cluster the different states in the US based on their reported number of police brutality. And k-means clustering is a top-down approach. It proceeds differently than hierarchical agglomerative clustering. And we have to use our data to determine the number of optimal clusters before we do the analysis, and because of that, it's a top-down approach. We also have to use these three criterion to decide on the number of clusters before we proceed with k-means clustering. And after we decide on the number of clusters, we use a kind of computer algorithm to randomly select a center for each cluster. And then we start to compute a straight line or Euclidean distance from each observation to the center of that cluster. And the center of that cluster is called the centroid. And the Euclidean distance is the most commonly used distance. And there are other options as well. And if we are not sure what options we have, we can always Google. And okay. Sorry, this is still not what we want. Okay, I think it should be under method. Yeah, sorry. Okay, so here are the different options for the distance measure. If we don't want Euclidean distance, we can select any of these options. And we can always find out more about these other options by Googling. Okay, sorry about that. So, after that, we recompute the centroid for each cluster after we compare the distances. And after we have a new centroid, we compare the distance again to the new centroid, and some observations may be reassigned to a different cluster based on their minimum distance to the new centroid. If the distance reduces the within clusters variation, observations are going to be reassigned to a new cluster. If their distance to the new centroid is smaller than their distance to the old or original centroid. So as you can see, k-means clustering proceeds in a different manner than the hierarchical agglomerative clustering. So if the distance is greater or the same, no reassignment is being done. The case or the observation remains in their original cluster. And these steps are repeated until further reassignment does not lead to reduction in within cluster variation. And in that case, there's no change in cluster membership. And the cluster assignment is almost fixed in this case, when there's no reduction in within cluster variation. So, if the reassignment does not reduce the within cluster variation, observations remain in their original cluster. But if the reassignment results in a reduction in the within cluster variation, observations are assigned to a new cluster. So, the steps involved in k-means clustering are different from the steps involved in hierarchical agglomerative clustering. And here are the other distance options we just saw by Googling. And here's the main differences between the two clustering approaches. In hierarchical agglomerative clustering, once observations are assigned to a cluster, they cannot be reassigned to another cluster, as we can see from here. They can just be combined with other smaller clusters to form a bigger cluster, but cluster membership do not change. But in k-means clustering, when we compare and recompare the distance among observations, sometimes observations can be reassigned to another cluster based on their distance to the new centroid. As we can see from here, we keep changing the centroids, and then we keep comparing the distances between observations and the new centroid, and we decide whether that observation should remain in the original cluster or they should be reassigned to the new cluster. And because of that, cluster reassignment is possible for k-means clustering, and the results of hierarchical agglomerative clustering. But it also depends on the type of linkage being used, can be affected by outliers or other influential observations. And results for k-means clustering are less affected by outliers or influential observations. And when we include irrelevant variables or features in our model to the point that we overfit that model, these may affect the findings of hierarchical agglomerative clustering, but k-means clustering are less affected by irrelevant variables or features. And this is due to the different procedures or steps undertaken by these two clustering techniques. If you look at hierarchical agglomerative clustering, it's a bottom-up approach. Initially, each observation is a cluster by itself. Then smaller clusters are being formed. Then bigger clusters are being formed. Even bigger clusters are being formed, and so on. Eventually, it's one big cluster. If we go by these procedures, we know that it's going to take up a lot of computation time. This is a more complex analysis than k-means clustering. So it demands more computation when compared to k-means clustering. because of the steps involved. And k-means clustering has a tendency to produce clusters of equal size in some instances but not all. But the equal size problem is less likely for hierarchical agglomerative clustering due to their different steps involved. Here are the steps for hierarchical agglomerative clustering, and here is the steps for k-means clustering. And because of that, we see all these different scenarios being played out differently between these two clustering techniques.